In this video, we are going to talk about how to solve equations called two-step equations. And they're called two-step equations because, well, they take 2 steps to solve. Not that magical of a name. We're going to jump right into it, and I'm going to go over 2 equations and how to solve them, but also discuss why our solution process, like why our thinking works the way that it does. Then in the second clip in this video, so a little bit later on, I'll go over 2 more problems in case you need the additional practice, but with a little less detail of the why the process works and more of just going through the process. So I'm covering you on all ends. Let's do it. We've got 4x plus 10 equals 26. So in terms of how we are going to solve this, you need to keep one idea in the forefront of your mind, which is you want to isolate your variable. You want to get x alone by undoing the order of operations. So how do we do that? Well, if you're solving 2-step equations, that means that you've solved 1-step equations before. To undo the order of operations here, we need to first recognize what's being done to the variable moving forwards. So let me show you what I mean. If I were to plug a number in for x and just do the order of operations on the left side right here. So let's say that we pick a random number, 2. I'm not saying that's the answer, but we pick the number 2 and we plug it in. So we'll get 4 times 2 plus 10. And if you look at the order of operations here, what we would do is we would first multiply by 2. So multiply x by 4, right? That would be 2 times 4, and then add 10. So the first thing we did was multiply by 4, then we would add 10. Well, that means that if I'm going to undo multiplication by 4 and addition by 10, I need to undo addition by 10, so subtract 10, and then undo multiplication of 4, divide by 4. That's what I mean by undoing the order of operations, and that's why the process I'm about to show you works. Okay, so I'm going to erase that right there. I just wanted to show it to you with a number. Let's dive into this. So the first process we're going to undo is the last thing that we would normally do in the order of operations. Plus 10. So we'll undo that with minus 10. What I do to one side of an equation, I must do to the other to keep the equation balanced. So focus first on the undoing of the order. That's what we want to do. Don't worry about this side. 10 minus 10 is 0. So they cancel out. They go to 0. You're left with 4x. We did nothing to that, so that's still there, is equivalent to, and now your brain should focus on simplifying that. 26 minus 10 is 16. Beautiful. Then we now have a 1-step equation remaining, which is sweet. So we want to focus on undoing multiplication by 4, so we divide by 4. So we're going to divide both sides by 4, like so. Focus first on undoing that side. 4 divided by 4 is 1. So we're left with x, 1 times x, or x. And then 16 divided by 4. Now focus on simplifying that. That is 4. And that right there is our answer. How do you check your answers? Well, I'll go over that one right now. To check your answer, you take the value you found for x, and just like in 1-step equations, we evaluate it back into the original expression. So the original, I should say, not just expression, but the original equation. The original equation was this, and we wanted to find the x value that made that true. So I take 4 and I replace it with x. So that's going to be 4 times 4. Remember that x is an open variable. So we're taking this 4 and whoop, plugging it in there. Plus 10 equals 26. Do a little bit of math here. 4 times 4 is 16. Plus 10 is 26. And that's a true statement. To be really formal, you would show that the left side is the same as the right side. So this right here is a check. To be very clear, this is the solution. This is me checking the workout real formally. Okay, we're going to go over one more 2-step equation in this clip, and then in the later part of the video, if you need that bonus coverage, I'll go over a couple more examples. Very cool stuff. Okay, with this problem here, you've got m over 3, or m divided by 3, minus 2 equals negative 7. So you want to undo the m divided by 3. How do we do that? Well, we also need to undo that minus 2. So the order of operations says you would divide by 3 and then subtract 2. Okay, well, if subtraction of 2 is the last order of operations to be done going forwards, it's the first order of operations to be undone. So to undo subtraction of 2, we're going to add 2. So we'll do that to both sides. All right, sweet. And so what we have left, well, we need to see. These undo each other successfully. So that's going to be m divided by 3 is equal to, now we focus on negative 7 plus 2. Think of that as a little bit of side work where your brain is only focused on that part. Negative 7 plus 2 is equal to negative 5. All right, so as we said before, minus 2 was the first of the things to be undone because it's the last in the forwards order of operations, so it's the first in the backwards. And then we have m divided by 3, so we'd have to undo division by multiplying. So I've chosen to multiply by 3. What I do to one side, I do to the other. Focus only on this. The 3's undo each other, and we're left with just m is equal to, and now focus on negative 5 times 3, which is negative 15. Beautiful. That right there is your answer, as it were. Okay, now let's take a look at how to check our work. Well, I'll put a little check mark right there. And so you have m over 3 minus 2 is equal to negative 7. Well, we are going to replace m with negative 15. So remember, I like to think of that as like an empty holding tank that we call m. I'm sliding a negative 15 into that spot. So negative 15 divided by 3 minus 2, is it equal to, I'll put a question mark, negative 7? Well, negative 15 divided by 3, notice the order of operations we're doing forwards here, is negative 5 minus 2 equals negative 7. And that is a true statement because negative 5 minus 2 is negative 7. Notice here that the order of operations supports what we did going backwards. We divide by 3, then subtract 2. We added 2, then multiplied by 3. That's pretty awesome, guys. So that's understanding the order of operations and how it comes into play with solving two-step equations. Stay tuned for a second video that's going to go over how to do these kinds of problems just with not as much process, a little extra practice for you. I will say this, earlier in the video I said it's going to be in the latter half of this video. The video went too long, we had too much fun doing it. So we'll add on a second video that you can watch for some extra bonus practice.